Welcome to another video from Roland Mösel, founder of Planetary Engineering Group Earth. General requirements for a Climate Protection Superiority House. It started with the primary energy indicator, the P value from Salzburg. This value was introduced in the new Building Technology Ordinance in 2016. And when the value is below 48, you get a building permit. When it's even better, you get more subsidy for making your house. And in September 2019, we make a first preliminary energy certificate for our project GEMINI Next Generation. And this ended with a big surprise. We thought maybe we are a little bit better. Yes, but the surprise was we have been far beyond anything else what was calculated with the p-value. Our p-value was minus 263. So the first version of Climate Protection Superiority House was in 2020. If your p-value is less than minus 250, it's a Climate Protection Superiority House. But we want to develop this p-value further. This p-value contains the following factors. Evaluating for the production of building materials, domestic electricity for 30 years, domestic hot water also 30 years, room heat, and also a form factor of the house. And because we mix unrelated values together, the p-value is a dimensionless value. We can hold any dimension at it. So first, evaluation for the production of building materials. Oh, it's very, very complicated. Far too complicated and long-winded. So we have to eliminate this very complicated procedure and replace it with kilowatt hour as a uniform standard to measure everything. We convert everything in kilowatt hours electricity. Oh, and how we do it with CO2 emissions caused by chemical processes. Very simple. We know how much electricity we will need to capture 1 kilo CO2 from the atmosphere and to split it in carbon and oxygen again. It's 6 kilowatt hours. So we just calculate every CO2 emissions with 6 kilowatt hours per kilo CO2. So the next is we have to eliminate the form factor of the house, because this makes the result without any dimension. And now we have our new calculation system. Electricity for the production of building materials and 6 kilowatt hours per kilo CO2 emissions. At room heating, we have to correct. We need also to calculate room cooling. Ask people on the west coast of Canada how surprisingly hot it can be and how dangerous for the life of older people this can be. Oh, suddenly 5-6 degrees above old records. Then we have also to calculate mobility. The people in the house will charge the electric cars. This has to come into the calculation. And at last, the exchange rate for electricity. You get 1 kilowatt hour for 6 kilowatt hours delivered. Oh, isn't it a very bad exchange? Oh no, because I made already 2 videos about the problem of summer-winter balancing of electricity. It takes much effort and the efficiency is low. This is the first video about it, summer-winter balance of electricity, and I made also another video, is Germany possible with 100% solar electricity? And in this video I made the calculations for the whole country, and there had been 180 gigawatt of power to methane units. There had been 50 cubic kilometer of underground methane storage, and there had been 80 gigawatt of combined cycle power plants. You see, it's much effort. The efficiency of all the turnaround is about 27% only, and because this has also to be all constructed, we make even a higher exchange rate, 1 to 6. Now let's look how this influences the calculation. First, there is concrete. To make concrete, you have to mix cement with it, and to produce cement, you have for 1000 kilo concrete 200 kilo of cement, and this emits 140 kilo of CO2. And we multiply it with 6, and we will evaluate it with 840 kilowatt hours per ton of concrete. For luck, the GEMINI next generation house is complete free of the usage of concrete. Next one is steel. As long as the reduction of iron is done by carbon, we have a CO2 emissions of 1.75 kilo per kilo of steel, and with this calculation we have 10,500 kilowatt hours per ton of steel. Here the GEMINI project is hit. This is 25,200 kilowatt hours for the used steel. Then the energy balance of the house, when we calculate it with 1 to 1, even in Oslo we have a positive balance of 12,500 kilowatt hours. But when we calculate, you have to feed in 6 kilowatt hours for 1 kilowatt hour you receive. This turns complete in the negative. More than 3,000 kilowatt hours in negative at Oslo. Only the more southern cities are in positive. About the calculation process, just right now, the calculation is with heat degree days, and you have to make only a multiplication with how much heat loses the house per Celsius temperature difference to the outside, and with a simple calculation, all is done. The next one, it is always heated to 20 degrees, never too cool, and humidity remains unconsidered. In this area, it's possible to let humidity unconsidered, but when you want to build the house somewhere near a hot jungle, air temperature 35 degrees, 90% humidity, and when you cool out down this air, the humidity goes above 100%. How is this possible above 100%? What's more than 100% is water running down the walls. And in the old calculation are simple devices with simple settings. Storage and storage strategy are completely unknown things. We have to replace this. We make the complete simulation with sampled weather values. In the sampled weather values is direct sunshine, diffuse light, wind, temperature, humidity, and precipitation. The next one, we have to replace 20 degrees by a tolerance band for the room temperature, because when you say 20 degrees and it's hot outside, you have to immediately cool, and this would be a waste of energy. So we say, okay, when it's so hot outside, we tolerate it to go up to 25, and when it's cold, yes, 21 is the minimum, and so it's to calculate. And also the humidity has to stay within 40% to 60%. And also the home control software is involved in making the simulation, because the home control software has to make always decisions about the optimal use of all the systems of the house. Now let's look on the replication factor. This is the new p-value. This replication factor tells, we used up 120,000 kilowatt hours to build the house. So at the start we are in the negative. And then there are the people living in the house, household electricity, domestic hot water, cooling and heating the house, and the people have electric cars to charge, and still the house has to have a surplus of electricity. And in the case of Berlin, in 30 years, the house delivers so much energy that you can build 1.38 houses new with this energy. This is a replication factor. So much energy that you can build other houses with the energy delivered. And we make this not only for Berlin, also other cities. In Vienna, the replication factor goes up to 3.17. In Rome, even 6.42. Only in Oslo, we fail to be positive, but Oslo has a really extreme location in the north. Now, what about a PlusEnergy house? The term PlusEnergy house is not protected. Everybody can use it and misuse it. There are even vendors who tell in their advertising prospect, we have a PlusEnergy house with only 4 kilowatt photovoltaic on the roof. That's a bad joke. We now take a PlusEnergy house with 15 kilowatt photovoltaic and 35 kilowatt hour of batteries. In Rome, it has a positive replication factor of 0.77. But in Vienna, minus 2.26, and in Berlin, minus 3.09. So this PlusEnergy house is far below what I would call a PlusEnergy house, even with this 15 kilowatt photovoltaics. Now there are people who tell us no new buildings, renovate old buildings only, and they make a cult out of it. Say, you should be ashamed to make a new building. And here is my message to these people. We take an old building and make a big renovation. Renovation takes only up 50,000 kilowatt hours. So there is a structure of the house. We have only to make better isolation, another heating system, photovoltaic, and batteries. And this takes up a little bit energy, but because this house takes 2 times more energy for heating, it's a good renovation, 2 times more. But this heating is only used in winter, and in winter the 6-to-1 exchange factor strikes here full, because only 10 kilowatt photovoltaics and 25 kilowatt hours of batteries, that is lost at the old house. And even in Athens, we have a negative replication factor of minus 1.3. And this goes higher and higher, and in Berlin it's already minus 14.4. So the method is make new Climate Protection Superiority Houses. Don't fool around with extensive renovations of old houses. This makes no sense. Farewell to complete inadequate objectives. What is an inadequate objective? Oh, we tried a little bit. Oh, we are so good because we already tried it. We failed by far, but at last we tried it. This is something for losers, and we don't want to lose against the climate catastrophe. We want to win this. And so we should have good targets and not joke targets. Our target with this house is not 100% renewable energy. This is only in between the real target. Just right now, humanity produces about 30 petawatt hours of electricity per year. With a very simple living standard, we could make it with 60 petawatt hours electricity for 100% renewable energy. When we make it a little bit better with power to fuel, power to gas, and so on, it would go up to 150 petawatt hours. But the range for the planet renovation is 450 to 600 petawatt hours, so far beyond simple targets like 100% renewable energy. The general requirements for the Climate Protection Superiority Houses is suitable for 90% of human settlements without any additional qualifications. You can make the house in Brandenburg, Germany, you can make it in Kuwait, and at both locations it would be perfect. Off-grid properties. Green means here no restrictions. Yellow means limited possibility to charge electric cars. Orange, moderate restrictions on household electricity, hot water and room heating. Red means severe restrictions. And black, oh, you can charge your notebook and smartphone, and the water pipes will not freeze. Black we have only in December and January in Oslo, because it's so far in the north that there is in December and January so few solar electric power that more is not possible. In any other locations, you have most time of the year no restrictions, and Rome down to the equator, no restrictions. You have always more energy than you need. So I said 90% of the locations, but there are locations requiring additional qualifications. Cold. Oh, it could have minus 50 degrees. The normal system is not designed for this additional qualification necessary. Imagine you are in California and the fire insurance says no insurance. This area is far too risky. What to do? You need additional qualification, fire protection. Then there is a qualification for grid interaction, for demand-based grid feed-in, for best possible interaction with the grid. Then for very high humidity and warm humidity areas, we need extra qualification humidity. Nutrition, that you can make your own nutrition in a glass house with vertical farming aeroponic. Rain absorb. A meadow absorbs rain. a normal house don't absorb rain, but in this case, the house should absorb more rain than a meadow. Snow wiper. Oh, it snows. Every other has a roof full of snow and cannot produce electricity. And your house has a snow wiper and the roof is free of snow and it lasts water. You can make the house in a high water danger area, and when the water comes, it should be good protected. Maybe it swims a little bit and settles down when the water goes away. This was another video of Roland Mösel, founder of Planetary Engineering Group Earth, and as always, like, comment, subscribe, hit the bell to be notified when I make my next video.